Today in this video we are going to see about hardware components and sensor network architecture of wireless sensor network. Wireless sensor networks combine specialized hardware components and structured architectures to enable data collection, processing, and transmission in diverse environments. Hardware components of wireless sensor networks. A wireless sensor node integrates several critical components to function autonomously. Sensors detect physical phenomena, for example, temperature, light, and motion, and convert them into electrical signals. These can be analog or digital, depending on the node design. Processing unit, typically a microcontroller or microprocessor that manages data processing, executes protocols, and controls node operations. It interfaces with analog to digital converters ADCs to digitize sensor outputs. Communication system, transceiver, a short-range radio module, for example, Zigbee, Bluetooth Low Energy for wireless data transmission. Antenna, facilitates signal propagation, often omnidirectional for broad coverage. Power supply, batteries or energy harvesting systems, for example, solar modules to sustain long-term operation. Memory, stores data temporarily during communication gaps and supports firmware for node functionality. Environmental protection. Nodes deployed outdoors may include ingress protection, for example, waterproof casing to withstand harsh conditions. Sensor network architecture. Wireless sensor network architectures are hierarchical and optimized for energy efficiency, scalability, and data reliability. There are 4 different sensor network architecture. 1. Node-level architecture. 2. Communication layers. 3. Network topologies. 4. Heterogeneity. 1. Node-level architecture. Sensor nodes, deployed in clusters to collect and pre-process data. Nodes may act as routers to relay information in multi-hop networks. Base station gateway acts as the central hub, aggregating data from nodes and interfacing with external systems, for example, the Internet. It can be static or mobile to balance network load. 2. Communication layers. Physical layer manages signal modulation, transmission, and hardware interfacing. Data link layer handles medium access control to prevent collisions and manage energy use. Network layer implements routing protocols to direct data efficiently, often using clustering or multi-hop strategies. Transport layer ensures reliable end-to-end data delivery via error checking and retransmission. Application layer translates raw data into actionable insights for users, for example, environmental monitoring dashboards. 3. Network topologies. Single hop. Nodes transmit directly to the base station, suitable for small networks. Multi-hop. Nodes relay data through neighbors, reducing energy consumption in large-scale deployments. Clustered. Nodes form groups with cluster heads aggregating data before transmission, optimizing bandwidth and energy. 4. Heterogeneity. Homogeneous networks. Uniform nodes with identical capabilities. Heterogeneous networks. Mix of sensor types and roles, for example, routers, aggregators for specialized tasks.